Hello again. I'm trying to make today a tutorial about heat conduction using fluent ANSYS and not transient conduction solver in ANSYS. So I'm going to make a two-dimensional object. It's a hook shape, and I will implement it in Fluent and activate the energy equation and do a few tricks to simulate the heat conduction from this area. So first of all, I'm going to draw the geometry. So I'm gonna try to do it again using Rhinoceros program. So like that, and then press enter, and then I'll go to this curve. I'm sorry, and alright, that's nice. I'll just go like no, that's too wide. Yeah. Something like that. Press enter, then I go down, I delete the shape, and I patch the surface, but before patching it I just join all the curves so they are joined. I use the patch command and that's it. Okay, so I saved the file and I'm gonna call it a hook. Save it. Yes, that's great. Now I go to workbench. Okay, so I opened workbench. Now I import the geometry. Oh, sorry, I don't import it over here. That's a big mistake. I choose Fluent, and like usual, I'll have to wait until it loads. And here it is. I right click on the geometry and choose new geometry. So we select centimeter and we import now the geometry. It is called hook, and we generate it. That's nice. The second, now the second step is to go to mesh. We edit it. We wait a bit. The thing is, in heat conduction, we have to select the boundary wall correctly. And now right, in the meshing part now, as I said, we have to select a correct boundary condition. So first of all, select this part and select this one as wall 1. This part as wall 2. So we have two parts, wall 1 and wall 2. And now we go to meshing, and I'm gonna mesh it as a cut cell mesh. Sizing is gonna be medium. Let's try it now. Okay, the mesh generation was not successful for some reason. I don't care, I don't want it anymore to be a cut cell mesh because we don't have time to make it work. So I'm gonna do it just a normal mesh generate. Oh, not again. What's wrong? Okay, the process suffered a non-handled exception or ran out of usable memory. Oh, alright then. So the process suffered a non-handled exception or ran out of memory. Of course, because I'm working on my laptop, which is very convenient. So I'm gonna decrease the size, the minimum size, and it's I'm gonna increase the minimum size. It's gonna be 5e to the power minus 3, and the maximum face size is gonna be 5e to 10 to the power minus 2. And over here it's gonna be 6e to the power minus 6e 10 to the power minus 2. And let's try now the mesh. Whoa, the mesh is absolutely crap. Alright, so let's decrease it a bit. Indeed, and like that, and like that. Oh man, and generate. Okay, the problem is I'm not focusing today because I have my last exam and I haven't slept yesterday. Alright, it's better the mesh now. I'm gonna decrease it a little bit more. 0.002, 3, and 4. Let's mesh. Alright, I'm gonna accept that for now. So the next step is just update it over here. Alright, and go to the setup. Alright, double precision. I never tried parallel machine. Let's try number of processes too. See what happens. I'm not sure it will work. It's nice to have experiments with you guys. It's not a bad idea. Alright, waiting for Fluent to open. What is the problem? Unblock and unblock. Oh man, don't tell me we've lost the. Okay. I don't know what's going on. Right? So I think it is done by now. Hello? Hello? Display mesh. Display. Close. Something is not working. Alright, here it is. So I go to model, I select the energy equation, it's activated, and I go to material. There's no fluent, it's aluminum. Cell zone boundary condition. Zone 1, it is a freaking solid, yes. Aluminum, exactly. Okay. And to the boundary condition, interior zone, wool 1 is a wool, which is this one, and edit thermal. I'm not gonna add a heat flux. I'm gonna add a temperature of 500 kelvins, and I'm gonna select OK, and go to wool 2, edit. So wool thickness is gonna be 0.3 meters, and it's gonna be it. Wait a sec, thermal. Alright. Okay, so I'm gonna choose on wall 2, which is this part of. I'm gonna choose a convection, and the free stream temperature is gonna be 300, and the heat transfer coefficient is gonna be, let's say, 25. So I'm gonna choose OK, and solution method. Okay, solution initializing. I'm gonna from wall 1 initialize and run calculations. It's gonna be 300, let's say, and start calculating. Right, it's busy doing what? Alright, if you're busy we can wait. There's no problem, I have all the time. Okay, so now it is calculating. What? Calculation is complete. Alright, let's see. Graphing and animation. And contour. Set up. Yes, everything. Temperature. What is static temperature? Total temperature. Compute. Display. Wow, that's pretty awesome. So here we can see conduction. The highest temperature is over here. It's around 500 Kelvin. Let's see, how much did you get on the wall 1 boundary conditions? Wall 1, edit. Oh yeah, it's 500 Kelvin. That's true. Wow. Okay, don't be amazed as I am. Anyway, it's 500 Kelvin, and it's gradually going down, and the temperature at the tip is 456 Kelvin. The free stream over here is, let's see, the free stream has a temperature of 300 kelvins and has a wall thickness of 0.3, so there is a cooling. That's nice. 25 is H actually, and the heat transfer that's happening between the body and the free stream is H T infinity minus T wall, or T wall minus T infinity. So that was about it concerning heat conduction and convection using Fluent. Hopefully you liked this, and just wait for more complicated problems. I would like to just make easy problems in order to give you an idea how things really work in these programs. It's not things that you really will encounter in your daily life, but at least it gives you like an idea how things works and how you can set up a more complicated software, a more complicated case. Let's go to graphic and animation and setup and see something else. Wall fluxes, for example. Right, that's nice. Remove. Okay. Oh, total surface heat flux display. Nothing interesting. Surface Nusselt number display. Nothing interesting. Let's see the velocity. There's no velocity, it's a solid, but anyway. And let's see something else. Properties. What is the property? Molecular thermal conductivity. Display. Oh, it's the same thing. It's 20. Molecular primary number. Alright, so that was about it. I'm gonna put the level 100 and go to temperature and enjoy looking at it. Yeah, that's beautiful. Alright, thank you for watching, and please stay tuned for more updated videos, and talk to you soon. Bye bye.